Hey guys, welcome to part 21 of my pre-algebra tutorial. In this part, we're going to cover multiplying monomials. In the last part, we covered adding monomials and what monomials are. Just go back and make sure you understand the term monomial, understand the terms monomial, binomial, and polynomial. We discussed those in the last part. And in this part, we're going to multiply monomials. So, a quick refresher from the last part, I'm just going to give you guys a quick problem. And I want you to ask me if this, I want you to answer to me if this is in simplest form or if we can combine like terms, combine the monomials together to make it simpler. I'm going to give you 5 seconds, pause the video. Well, we couldn't because y squared and y are not like terms. They're not the same variable, ergo the two monomials are not like terms. Now, multiplying monomials is where it gets a little bit more complex. But let's just start with the very basics. First of all, adding monomials is a little bit more complex because you have to worry about like terms. And then after finding like terms, you only add the coefficients, not the variables. With multiplying terms, you can multiply literally anything together. All variables can be multiplied together to net a simpler variable. So let's say I have a variable x, and while in reality variable x is equal to 3 and y equals to 7, just keep that for later, I'm not going to worry about that, and I'm just going to say I want to multiply my x times your y, and I want to get the simplest answer, but I want to just use variables. Well, to do that, it's basically asking, if you recall, I might have told you that this is another way of writing multiplication. The simplest way of writing it, xy. It's basically saying that all these variables are being multiplied together. So let's try another one. Let's try 5x. No, let's try x squared times y squared. What would be the answer to that, do you think? Well, we're multiplying these two variables together. So we're basically going to omit the multiplication sign, and then we're just going to get x squared y squared. Seems simple enough? I hope so. If not, rewind and try to get that again. Now, remember what I said. When you have to add monomials versus when you have to multiply monomials, you have to worry about a lot of things, like combining like terms. Like x plus y could never happen. X plus y is in simplest form, but x times y, xy. So this will be 3x. Alright, and let's not worry about that just quite yet. I'm going to get to that. Now, you're going to want to multiply your coefficients and your variables separately when you're multiplying monomials. For example, let's say we had 5x and we multiply that by 6. Basically what we have here is another way of writing it. It says 5x times 6. And we want to get the simplest answer. Well, you're going to want to multiply your coefficients first. Your coefficients, so 5 times 6 is 30. And then multiply your variables. There's no variables, so we're just going to bring the x back over. And let's say that x equals 3, just to prove if this is right. So 5x times 3, 5 times 3, which is 15. 15 times 6 is 90, I believe. Yep. And then 30 times 3 is also 90, so this does work. Remember, just multiply your coefficients. Let's get a little bit deeper. Let's see here. Let's go with something else. Let's go with this one right here. Let's say I had 9y to the third power times 6x squared. So basically what I'm saying is I want to multiply these two together. My step was to tell you to multiply the coefficients and the variables separately. So 9 times 6, which is 54, times y cubed times x squared, which would be, as we learned in the last part, we just push them together. X squared y cubed. But we just learned that a couple minutes ago. It wasn't exactly in the last part. So our answer is 52x squared y cubed. Let's say actually that we had the same variable like I just showed you, 2x times x. What would the answer be? Well, I mean, your first guess would probably be to say 2xx. But when you have a lot of variables together, more than one variable, we tend to want to use a different form. Now recall way back when I told you guys that multiplication, it goes addition, multiplication, and then from multiplication, if you're multiplying the same thing over and over again, you go to exponents. So So you're multiplying two x's together. So another way of saying that would simply just to be saying x squared. Just like saying 4 times 4 is the same as 4 squared. They both will get you 16. That's not 42, that's 4 squared, by the way. So we're going to, instead of writing it that way, I mean, that would technically be okay, but it's not in simplest form. We're going to want to write squared. So you combine the two variables. Let's try that. Let's try one on your own. Let's see if you can get this. Let's say I had 9y squared times y. This is an extension off of what we just learned just now. Well, if you're getting confused, you're gonna always want to remember you can always write this out in the long way. So 9 times 9 times nothing. Okay, 9 is gonna remain the same. Y times y times y. How many y's are we dealing with right here? 3 y's. So y times y times y. And if you might know, y times y times y is the same as saying y cubed. Y cubed is basically, this number right here tells you how many y's are being multiplied to the y. So y to the 6 would be, as you imagine, 6y. 1, 2, 3, 4, 5, 6. So if you're getting confused, you always can do this. But I'm going to show you a shortcut right about nowish. Let's say you had something huge, like x to the 3rd times x to the 94th y. Just throw that in there. Obviously, you could always try writing it out and thinking about it, but a simpler way, it would be simply just to add the two numbers on top, x to the 97th y. So, rule of thumb: when you're multiplying variables, and you see these exponents on top, just add them together, and you get 9 times x to the 97th, and then y. Always bring your y down. Don't lose them or anything. They can't be missing in action or anything. Alright, let's go for a little bit more complex one. Just want to see if you can follow these. I hope I'm not going too fast when I'm teaching you this. There's really nothing much to teach. It's just noticing and responding to it. Just learning a few things, like last tutorial I taught you addition, which was basically saying you have to check to make sure like terms are same. If like terms are same, add the coefficients. This time I'm just telling you, just multiply the two together. But you also want to try to combine the variables. So first things first, coefficient times coefficient. We're gonna get 24. Next, I want to go for an x. Anything with a base of x. All right, base of x. So 2 times 2. X squared times x squared. Remember, add these two. 2 plus 2 is 4, so we get x to the 4th. Okay, we finished that. Y cubed, and we have 2y cubed, so y3 plus 3 is y6. Y to the 6th power. And then q is not being multiplied by anything. So we just leave the q and bring it back down. So our answer was 24x to the 4th, y to the 6th, q. So basically, multiplying terms is a lot easier than adding terms. I'm just gonna tell you guys one more time what I taught you guys. X anything times anything. You first multiply coefficients and then multiply the exponents. And like I said, you count up the number of exponents. You count up the number of variables multiplied, and then you write them like that. Now, why wouldn't you write it like if you had 4x times 4x, why would you like not write it 4 squared x squared because you have two 4's? Well, that's because we know the quantity of 4 squared. We know that 4 squared is going to be equal to 16 no matter what because it's a constant. Whereas x squared could be equal to different things depending on the value of x. So we can't really say for sure what x squared is going to be, but we can say that whatever it is will be multiplied by 16. That is basically all I have for you guys today. See you guys in part 2022 actually, when we work with dividing monomials. That'll be fun. See you guys later.